In this session, we are going to discuss a problem based on periodic functions using Laplace transform. So here the function of t is k into t divided by capital T. The range of t is 0 to capital T, and they specified very clearly the period is what? T. By the definition of Laplace transform of a periodic function is one over 1 minus e to the power of minus s into capital T integral 0 to t e to the power of minus s into t f of t with respect to t. We have to use the given function. It is k into t divided by capital T. So let me substitute that. 1 over 1 minus e to the power of minus s into capital T, because the period is capital T only, so the parameter we specified it capital T. So integral 0 to t. See, in this interval the function is defined as k into t divided by capital T, and here e to the power of minus st. Let me write the same. We have to integrate this with respect to t. We are integrating with respect to small t. So k by capital T plays a constant role. Let me take outside the integration symbol. So that is 1 into k. It is a k divided by capital T into 1 minus e to the power of minus s into capital T integral 0 to capital T. We have a function now e to the power of minus s into small t into small t. We are integrating with respect to small t. We have to observe that the integrand, which consisting a product of two functions, while integrating we know the integration by parts, that is integral u v. Suppose we are taken with respect to t, we have to use Bernoulli's rule. Bernoulli's rule will be says that which we have a function with a polynomial, we have to take part of that polynomial as a differentiation, because the derivative of the next part will be having to reduce the power of the function. For that sake of the reason, we are taking part of the polynomial as a derivative aspect. In this function, this t is we are taking part for the differentiation. So let me recall the basic thing of integration by parts. The first function, integral of second with respect to t, alternative positive negative, the differentiation of first, integral of second, that is we are integrating this integral of v with respect to t, alternative positive negative positive. We have to continue this process till we are getting the derivative as a constant rule. Let me adopt this Bernoulli's integration by parts in the given problem. So in this problem, the t will be placed a polynomial, but the degree is 1. See, the differentiation of t with respect to t will becomes 1. So therefore, we are taking part the t as in the differentiation. So let me see. This term will be retaining same. So first function is now t integral of e to the power of at with respect to t is e to the power of at divided by a. So this is indefinite integral. That's what we are writing, integral constant as c. But in the current problem, we have the limit. So we are dealing with the definite integral. So that's what this constant will not appear in the present problem. So now let me compare with the standard formula of the given function. So e to the power of minus st, instead of a, we have minus s. So let me replace that a, wherever we have a, we have to replace it by minus s. So that is e to the power of minus st divided by minus s. So alternative positive, negative. The differentiation of t with respect to t is 1. The integral of e to the power of minus st is e to the power of minus st divided by minus s. We have one more minus s here. So minus s into minus s, it is minus s whole square. So the limits from 0 to t. See, we stop up to the second term because the differentiation of 1 is 0 in the next part. So 0 into anything is 0. So not necessary to write. Where we will get the constant term of the differentiation, we have to stop there only. So now let me apply the limits. So this constant term, let me keep as it is, minus 1 by s. Let me take outside the limit. We are applying the limit for t, that is small t. Okay, let me apply first upper limit. Upper limit, wherever we have a t for this function, you have to replace by upper limit, that is capital T into e to the power of minus s into capital T minus lower limit. The lower limit is what? 0. 0 into anything is what? 0. Same thing. Say minus s whole square is what? Plus s square, right? So let me take minus 1 by s square outside. Now we have to apply the limit for the function e to the power of minus st. Apply the upper limit. Upper limit is t. So we are replacing small t by capital T minus lower limit. See, e to the power of 0 value is what? 1. E to the power of 0 value is 1. So now when you apply the lower limit, minus s into 0 is 0. So e to the power of 0 value is what? 1. Now let me simplify this. The Laplace transform of this function as k divided by capital T into 1 minus e to the power of minus s into capital T into, let me multiply this. See, 0 into anything is 0. So that's what we are multiplying only to this term. That is 1 by s into what? T into e to the power of minus s into t. Let me take this next term. This minus 1 by s square we have to multiply inside. So what we are getting as minus 1 by s square e to the power of minus s into t. Minus into minus is plus 1. Or else you can multiply k by t into 1 minus e to the power of minus st to this function inside also, or else you can be retain the same. So let me conclude. The Laplace transform of the given function is, I'm going to multiply this. Let me multiply minus k into, see, when we multiply this to the first term, we have a t in the numerator as well as in the denominator. Let me cancel it, and the remaining in the numerator term is e to the power of minus s into capital T divided by, in the denominator we have s along with what, 1 minus e to the power of minus s into t. Next, let me multiply this term to minus 1 by s square into e to the power of minus st. So what is the remaining we have, or else you can be take it as 1 plus also, or else let me take the k by t square into 1 minus e to the power of minus st to the second term. So what is the remaining we have, minus k into e to the power of minus s into capital T divided by capital T into s square e to the power of minus s into t. We have here 1 minus. So let me write 1 minus e to the power of minus st and plus, multiply to this next third term also, plus k divided by t into 1 minus e to the power of minus st.